Okay, to review covalent bonding, basically just means that there is a sharing of electrons between the atoms, and most of the time this sharing of electrons or a covalent bonding occurs between two nonmetals. First of all, let's just go look at this example right here, F2. The fluorine atoms each have 7 valence electrons right here. And in order to have the complete octet, they need one more valence electron. Since there isn't a cation that can donate an extra electron, what they have to do is share the electrons between them. So when taking a look right here, what each of the fluorine atoms now has 8 electrons because one electron from each of the fluorine atoms is being shared. And that is what is known as covalent bonding. And the chart that is right here above is showing the different examples of single, double, and triple bonding and what each of these entail. So first of all, this is not something you probably learned in Chemistry 1, but in Chemistry 2 there are something called sigma bonds and pi bonds. Sigma bonds are basically the first covalent bond between two atoms, which is basically the single bond. And the pi bonds are the additional bonds between the atoms. So when you have a double bond, the first bond is a sigma, and the second bond will be a pi bond. So you can see that breakdown right here. The single has 1 sigma bond, the double has 1 sigma and 1 pi, and the triple has 1 sigma and 2 pi bonds. The bond order is the number of bonding pairs of electrons between two atoms. So basically when you have a single bond, there's only one pair of electrons that's being bonded, so one side of bonding. So the bond order would be 1. And for double, there will be 2 bonding sites or 2 pairs of electrons that are bonding. So it would have 2, and for triple, it would be 3. The bond length is for single would be the longest, for double it would be in the middle, and triple would be the shortest. Basically, the more bonds that you add between the two atoms, they're being pulled together more closely, so the bond length would shrink. So basically it's like they're overlapping, so they're starting to shrink. The bond energy for single would be the least, double would be in the middle, and the triple would be the greatest. The single would be the least because the two atoms in the bond are very far, are like spread out. However, in the triple, since there is a lot of attraction between the two atoms, they're being pulled together more strongly, and it would also take a lot more energy to overcome a triple bond than a single bond. So that's covalent bonding.